All right, in this lecture, we're going to cover what it's about when it comes to modeling objects in Maya. What are the different types of geometry? So we have polygons, NURBS, and curves are the three main types that we're going to cover here in this lecture. So polygon objects are the most common ones. They're made up of faces, edges, and vertices. And polygon modeling is mostly used for pretty much lots of things, but for 3D models created for games, film, web mobile devices, VR. Yeah, it is very versatile and the most popular form of modeling. So a lot of times we'll just go straight to polygon modeling. There are some there's some advantages to the other types of geometry, and we'll talk about those in just a sec here. But just to understand that polygon modeling is the most common. And so here's the components of a polygon. So you have vertices, which are the individual little points. Then you have an edge, which is the connecting the 2 points, a line essentially. And then if you have an enclosed shape, creating the face essentially. And you have 3, 4, 5-sided, 6-sided, so forth. Anything above 4-sided polygons are called n-gons, meaning they're just non-planar. They will basically pinch and distort in terms of any textures you apply to them. So n-gons typically are bad. You usually want to stick with 3 or 4-sided polygons, but they can basically combine into any kind of mesh. You can see here a face here on the right here that has lots of 4-sided, and there's a few 3 in little corners here, but typically you want 4-sided polygons. So this T-Rex here is made up of polygons, and that I created. And here is NURBS, which stands for non-uniform rational B-splines, and they're basically, it has to do more about with how the geometry is created. They do it in terms of what they call U and V directions to create the patches. They're generally smooth and used in industrial design. Some animation and scientific visualization areas will utilize it. But NURBS it's a lot more limiting in a lot of ways than polygon modeling, and so it's technically not used that often. But I'm going to share with you the differences between them and how I use them in geometry. So here's an example of some NURBS where you have checkerboard, spheres here being applied. Here's some NURBS curves, which is the third part of geometry that we're going to talk about. They're used for constructing objects for both polygon and NURBS surfaces. They can also be used for motion paths and animation, and controls and animation, and controls for other deformations. So essentially the NURBS, the curves actually connect the plane, which you can see there, that's being mapped around that sort of cone-like surface. And here we have the T-Rex again that I modeled, which is full of polygons, but it has NURBS curves, which are these weird shapes around it, and all those weird shapes are essentially controls that allow me to manipulate and move the dinosaur. So that's the very quick lecture with a slideshow that I have offered you, but I am going to go a little more detail here in Maya, the difference between the two. If we look at the polygon object here, we're going to look at the outliner here. Again, if you don't have your outliner open, you can click on the bottom left icon here, and that'll pop up with the outliner. This is a cube here, which is a polygonal cube, which is a polygon shelf here. This object here is a NURBS cube. It looks pretty much the same, but it's a NURBS cube. And you can see here it's a group. If I open up the little plus sign here, you can see these individual components. So when I click on a piece here, I'm actually separating out the NURBS geometry. Where if I select the polygon geometry, it's one whole unit. It's basically connected. So if you right-click on an object, you'll see on a NURBS object you have isoparms, you have holes, surface points, control vertices. So there's a little bit of difference in terms of the geometry here. What is an isoparm versus a hole, for example? So over on the polygon object, you have vertices, edges, and faces, which are the most common aspects of these. In the two spheres here, which go back to object mode on both these. If you click on the polygon sphere here, you can see again it's made up of just a sphere. Collapse this cube here. But if I click on the sphere, the NURBS sphere, it's a NURBS sphere, but and it's one whole solid object, but it's a little bit different in terms of its construction. Where we're going to find that out is in the channel box here. So if I click on the polygon cube and open up the polysphere, here's the radius and the subdivisions. So the radius is basically how big or small, right? And by default it's set to 1. And then the subdivisions are the axes here. I can add additional or subtract the amount of subdivisions in here. But again, default on the sphere is 20 and 20, so I'll leave that alone. But watch what happens when I click on the NURBS sphere. If you click on it and open it up, you have some different options here. So the first one is the radius, and again I'm just middle clicking on the mouse to drag to change that value. Then I have this value of the start sweep, and as soon as I do that, you start to see what happens. It's essentially that the plane geometry is being folded over to create this sphere. So there's a start end sweep and an end sweep to create that whole 360, which is the degree of the sphere here. Then there's sections. So there's 8 sections here. So that's kind of like subdividing it. I can also subtract from there. And then the spans go along the horizontal there that I can change. And then there's the height ratio, which I forgot what that one does, but it's not affecting it. So we'll leave that one alone right now. But the important thing is between these two is how it's mapped in terms of its UV coordinates. If we open up the UV editor by click on UV here and go to UV editor, the checkerboard here, which you can see is a pattern here, when I click on the sphere here, you'll see these little triangles here and how the mesh is being displayed on there. Where if I click on this sphere, you'll see here it's a very flat plane. It's perfectly square. There's no little jagged points. The polygon has these jagged points because of these poles at the top and bottom. So you can see these are triangles up here, and that's being reflected right here along here. So in terms of the geometry, it has a lot to do with how the texture is applied, but also the look and feel of it too, and it can change a lot. For example, if we apply, let's apply this object with that same material. So I'll select it and right click, assign existing material, and I'll choose that checker. So now that one has checker, and then I'll click on the group and hit the G key, and you can see here the difference that's happening here. So if we click on this one, we have an unfolded map of the cube, which is the polygon cube, where this one, if we click on all of these individual pieces, they're all being mapped on the full UV format. So that's why it's very small in terms of the this checkerboard pattern, where on this one it's very large. If I was to come into the UV editor here and select the shell and scale it up, you'll see I can get and then click out, I can get the cubes to essentially get closer with the checkerboard pattern. It gets closer to that one there. It's essentially what's happening there. But anyways, there are some major differences between the two pieces of geometry. Curves, again, are used for various things, and they have a whole menu shelf here, the curves and surfaces. Here's all the surfaces you can choose. But surfaces are really nice. We're going to explore this in another project called the Pottery Project, where we can do some fun modeling with curves. But a lot of times you can also animate things along a curve. So, and again, if I scale this up, for example, I could have an object, like a polygon object, basically animate and fall along that curve, which is really cool. Or I could use this as a control to control the animation of this object here. In fact, I will pause this video here real quick and open up another scene to demonstrate that. Okay, so you can see here in this spaceship model that I created, if I hit play, I've got some animation, and you'll see that the curves follow the actual spaceship, but each of these curves do something. So for example, this NURBS curve here, if I hit W on it, and I start to move it, what's going to happen is this gun turret here is going to follow this curve wherever I move it, rotate around. So that's kind of cool. This other one here, if I click on this one, it creates channels here, or there's channels located on this main curve, which has, so it's a control in that sense. But like, for example, I can adjust the thrust here of the engines here, or there's some like tail rotation, right, that happens here. So you can see as I drag the little slider here, I can kind of adjust that and do all those things. There's a center of gravity channel. There's all kinds of things that are really cool with these curves that are created for the controls. But these two on the sides, they basically, allow the gun turret to move around. This one here is a center of gravity. So as I move this up and down, basically can pull up and down aspects of the scene here when it's locked in. Right now it's unlocked. So, but it's another form of control. But let's go ahead and hit play, and you can kind of see, different things are happening here. You got the guns, the pivots there, even the wheels. No, these the landing gear is not animated. I forgot that on here. But if I select this and go down to, where is it here? The landing gear. Here we go. These are all the landing gear. There's flaps and everything. So if I middle click and drag, you can see the landing gear actually is ready to be animated and move along here. But it's connected through a node editor, so it's connected through what's known as set-driven keys by this control on this channel box here. So NURBS curves have lots of purposes. This is for rigging, but we will see it in modeling and again, a future project called the pottery project. So that's it for this modeling overview. I hope you enjoyed this lecture. Until next time, see you soon. Cheers.